So good morning, all of you. Good morning, all of you. Hello, can you hear me?
Yes, ma'am. Good morning.
Yeah, thank you. So we start with a new chapter, lesson number 11, work
Work
and
with energy.
energy. Exactly. This person is Joule, James Prescott Joule. This one on the left hand side. This one, James Prescott Joule. So he is Joule. Okay, one on the left hand side. And the right one is James Watt. This one is Watt. I hope you know steam engine, right? He's the founder. So all these two are renowned scientists. Now we'll talk about work. Talk about work. What is work? Now, while reading, if you can explain, I would be too happy. Okay? If you can. So it's totally up to you. I will be explaining nevertheless, but if you can, it's well and good. Yes, please begin.
Work. If you push a box with a force of 1 Newton for a distance 1 meter, you have done exactly 1 joule of the work.
So, what is it? Now there is a box. There is a box. You are pushing the box. Obviously, there is a force, isn't it? You're applying a force, then only you can push the box. Agree? This force is of 1 Newton, and the box is moving from here to here 1 meter. So, how much work is done? 1 joule. Got it? This is the definition. So, what is work? When you apply a force of 1 Newton and the object is pushed by 1 meter or it is displaced by 1 meter, then 1 joule of work is done on that particular object. Is it clear? Abdul,
Yes, ma'am.
is it clear?
Yes, ma'am.
All of you?
Yes, ma'am.
Any problem? So you can ask me again so I can redo it. Now you explain otherwise. If you have understood, just explain what is work in your own words, please. I'm not removing anything. Just explain in your own words. What is work? Please begin. Hello. Yes, Sahim. Abdul. Any of you can. Can you hear me? Boys, can you hear me? Hello. Can you hear me, beta? Hello. Have you understood what is work? Hello. Hello.
Yes, ma'am.
Okay. I thought I have to start all over again. Can you see the slide? Can you see the slide? Boys, can you see the slide? Hello? Hello? Can you hear me?
Yes,
Abdul,
ma'am.
can you hear me? Okay,
Yes,
can you see the slide? Can you see the slide? Please be a bit louder.
yes, ma'am.
Okay. So have you understood what is work? So you can see over here, this is the box. This is a box, right? And it's been pushed with the force of 1 Newton. It is displaced by 1 meter, and here is the box. And we say that 1 joule of work is done on this particular object. Any problem whatsoever? So
No.
you have understood what is work? Okay. What is this? Work is force is parallel to distance. So obviously, what do we say? Now I am applying a force like this. Even distance is applied like this because it is moving to that particular distance as to the direction of the force. Even the distance is towards the direction of the force. Yes? If this is force, then this much of distance is covered, is traveled by that particular object. What do you say? So it is parallel. Force is parallel to the distance. You agree? This is
Yes,
force
ma'am.
and this is distance. You agree? Okay. So what we come to conclusion that work which is done on any object is equal to force into distance. So what will the unit? Force is Newton, distance is meter is equal to. So if I say joule, what is joule? Then what will be your answer? Newton meter. Have you understood this much?
Yes.
So what is joule beta? Newton meter. From where we got Newton? Force, meter,
Force.
distance.
Yes.
Yeah, force is Newton, distance is meter. So Newton meter becomes joule. This much is clear?
Yes, clear.
Okay. So this you have to remember. This formula you have to remember throughout. Okay. What do you see over here? A man climbing the stairs does the work. Just yeah. So this man is moving up the steps. So he is moving from this place to this place. So what is covered? Distance is covered, isn't it? So when a distance is covered, that means this man has left the initial position and came to final position. So he's traveled a particular distance. That means he has done the work. You agree? Yes, boys, do you agree that he has done the work?
Yes.
Yes? Okay. So what is important? Distance is important. So distance shows that a person or an object has done the work, right? Okay, please one of you start reading. I've already given the examples. Now we will do the detailing. Please continue.
Work is said to be done when a force acts on an object and the object is displaced in the direction of the of force.
Okay, do you
The
agree this
work.
statement? Just a moment, Abdul. Do you
Yes,
agree with
ma'am.
this statement? This is what we had learned in earlier slides, right? That it is parallel, the force and the direction of force is parallel, the displacement, the distance is parallel to each other. And why we say that work is done? Because we are applying a force on an object and the object is displaced from the initial position to the final position. And the force and the direction of force is parallel. The displacement is parallel, right? Okay, next.
The work done on an object is the product of the force applied and the displacement. Work done is equal to force into displacement with W is equal to F into S. The unit
I
of
had
work.
taken, just a moment,
Yes,
instead
ma'am.
of S, we had taken D, isn't it, in the
Yes.
earlier slide? So it doesn't matter, we can take any symbol, but we should know the formula. Work done is equal to force into displacement. Why we call it displacement? Because the object has left this initial position and has gone to final position. So the distance covered is actually the displacement. Have you understood? The distance
Yes.
covered is the displacement because the body has left this position and has gone to this position. That's the final position. You understood better? Okay. So what is the formula? F into S. Yes, continue.
The unit of work is Joule.
Joule,
If
Joule.
F Joule,
Hello,
Joule.
Joule. So we
Yes.
know this also. The
Yes.
unit of work is Joule. Okay. So one, like sentence by sentence, we are going to learn. Let's not be in a hurry. Okay. Now say
If F is 1 Newton and displacement is 1 meter, then the work done is 1 nm or 1 joule.
said you say 1 nm. Don't say 1 nm. You say 1
Yes.
Newton meter. What you will say, beta?
1 Newton
1
meter,
exactly.
1
Or
joule.
1 joule. So this also we have learned.
Yes.
This is revision. That is what I'm saying. So learn with each slides. Okay? Fine. So
So 1 joule is the amount of work done when a force of 1 Newton displaces an object by 1 meter.
displaces. Beta be careful. It is
Displace.
displaces.
Yes,
It's not
displaces.
displace. Be careful. Yes, an object by 1 meter. This also we know. So what is 1 joule work? Is the force of 1 Newton when the body moves by 1 meter. So we get the work as 1 joule. Am I right?
Yes, ma'am.
Now let's do an example showing the relation between the force, the displacement. Yes, let's see.
So, 1 joule is the amount of work done when a force of 1 Newton displaces an object by 1 meter. Example, if a force of 5 Newton act on an object is
Acts.
displaced.
There's the
Yes,
S
ma'am.
over there. Acts. Don't say
Acts.
act. Yes, there is a S, isn't it? So be careful in putting S
Yes.
and
Acts.
pronounce it properly.
Acts on an object is displaced through 2 meter in the direction of force. Then work done is 5n into 2 meter is equal to 10 Newton meter or 10 joule.
You understood? What is force
Yes.
bit over here? 5 Newton. So what you will write? F is equal to 5 Newton. Right? What is displacement? 2 meter. So S is equal to 2 meter. Yes? What is work beta? Force into displacement. Right? So what we will put? We'll put the value of F and S. So what is F? 5 Newton. What is S? 2 meter. What you get? 10 Newton meter. And we know Newton meter is also called as joule. So what I will put? Instead of Newton meter, I will put joule. Any problem, beta?
No.
It's simple?
No, ma'am.
No, I mean, is it simple to
Yes.
understand? Okay,
Yes.
fine, good. Yes, read.
Work is said to be
Work
done.
is said,
And
beta. Work is a said, no. There's no a over here. Work is
work
said
is
to be
said
done.
work is said to be done scientifically when a force applied on a body produces motion in it.
Thank you. So now you read it properly. I'm very happy about it. So what what you people do actually, it's become a habit rather, or you have become a bit casual that you can put article a and the as you wish. Don't do that. You can delete article as you wish. Stop it. So whatever is written, please read properly. Then only we can understand the usage of articles. Got my point, beta? The way we read, the same way we learn. If you read wrongly, you will learn wrong things. You understand what I'm saying? Yes? Do you understand better? Hello?
Yes, ma'am.
Hello? Do you understand now what am I saying? The small, small things we have to learn every day. Okay, beta? And you have to improve our English as well. That's the reason why I'm a bit careful regarding you people reading it properly. Okay? So, what is work? If we talk about scientifically, the work is applied on an object when a force is applied. Work is done on an object when a force is applied, and when that force is applied on the object, the force produces motion in the object. Am I right? Hello? Or do you have to say something about it? Hello? Boys, can you hear me?
Yes.
Yes. So, what did I say? Force is applied on this object. This is the object. Force is applied on this object. So, this force is producing motion in this object. And when the body starts moving, a distance is covered. Right? You understood what is happening? If you have not understood, you ask me again,
Yes, ma'am.
please.
Understood.
All of you, whoever
Yes.
has joined, all of you understood better? Sahi?
Yes, ma'am.
Understood?
Yeah, ma'am.
Okay. And one more thing I really want to relate is that if you feel like these are all activities, remember? You can see these are all activities. If you wish, then you start teaching me. I would be very happy with it. If you think you can explain, you can stop me right away and you can interrupt me. You can interfere also and you can say that, ma'am, I wish to explain. It would make me very happy. Can I expect this from you people? Hello? Can I expect that you will stop me in between? Boys? Why there is no response? Hello? Hello?
Yes, ma'am.
Yes. Do you hear me? What I said just
Yes.
now? Okay, so I'm looking forward that one of you will stop me in between and will take up the explanation. Yes? Now please read.
Work done in moving a body is equal to the product of force exerted on the body and the distance moved by the body in the direction of force.
Is it something new or we already know about it?
Ma'am, it is new.
It is new. You find it new better?
No, ma'am, no, it is not
But
new.
that is what I said. We have already done it. In all the slides, we are doing this better. Okay, doesn't matter. It happens. Don't worry about it. Okay, now read the second type of definition better. Or
Or work done in moving a body is equal to the product of force exerted on the body and the displacement of the body.
okay,
Work
do we
done
know this?
is equal to
No, do
force
we
into
know this?
displacement. W
Abdul,
is equal. Yes, ma'am.
do we know this
Yes.
definition?
Yes.
Yes? Okay. Then,
W is equal to F into S.
so we have come to conclusion. We already know about it. So we have learned it. So what is work? Force into displacement. What is work? Force into displacement, where work is 1 joule is equal to force is Newton and S is meter. So what we found? 1 Newton meter is equal to 1 joule, and that is the work. You understood? This is the work done. Tell me any problem? So we have talked about work in so many ways, taking different slides, did certain activities, we took examples. I hope things are very clear to you regarding the work. Yes, boys. Do you have any doubts regarding work? Yes? Now we are going to summarize what exactly is work. Please begin.
Work is a scalar quantity.
What is scalar quantity? Where only
Scalar
magnitude is no, where only magnitude is taken up, there is no direction. That is called as work. What is vector quantity? When we have both magnitude as well as direction. You understood?
yes.
Okay. Then what is the second one?
Work can be positive or zero or negative.
You understood? So it has a zero. It has signs as positive as well as negative, and it can be zero also. Okay. Now we'll see one by one. Why is it negative and why is it zero and why is it positive?
Negative work does not mean it a vector quantity.
Quantity.
Work done by friction is negative
You
as the
understood?
displacement is opposite to the friction.
You understood now? Why it is negative? Because friction. So work is done against the friction. So it is negative. So work done is negative. You understanding why it is negative? Because it is working against the opposing force, that is the frictional force. So we call work as negative. Next,
SI unit of work is Joule or J.
joule. It is
Ah, yes,
joule,
ma'am.
better.
Joule, Joule.
And be a bit louder, better. Just adjust your mic.
Yes, ma'am.
You're very faint
1 joule
now.
is equal
Huh.
to 1 Newton into 1 meter. Yes, ma'am.
Yes, now it's okay.
Yes. Or 1 J is equal to 1 nm. 1 joule is the amount of work done when 1 newton of force acting on our body displaces it through 1 meter.
This you know. Regarding Joule, you know. We just did in first slide, remember? And this is the ninth slide we are doing. The very first slide we had come across, the joule is the amount of work done when 1 Newton of force acts on a body and it displaces it through 1 meter. The first slide. Should I show you the first slide, beta? Remember? This is what we had done. Okay, so you know that we had already done it. Fine. Now, this is SI unit. Now, we will talk about the CGS unit. Please begin.
CGS unit of work is ERG.
ERG.
1
What you
joule
will
is
say?
equal to
ERG. Beta, it is ERG. You
erg,
cannot say like that. Yes, it is ERG. ERG is ERG.
erg.
So now let's see the relation between
1
joule
joule
and erg.
1 joule is equal to 10 upon 7 erg
10 raised to
or
7, beta. It is
yes,
10 raised
10
to
raised to
7.
7 erg or
Or
1 erg is equal to 10 raised to minus joule.
minus 7. It's just the reciprocal, isn't it? So it becomes 10 raised to minus 7 joule. So this is the relation between the erg and joule in CGS system. But don't actually use the CGS system. We always use the MKS system, that is SI unit, right? So now we are going to take it as the unit of work as joule and nothing else. Am I clear?
Yes, ma'am.
Am I clear? Okay. So all of you have understood regarding work. Now let's see what sort of work are we doing. Yes, please continue bit and then I will show you the activity. But let's first read it. Start.
For work to be done, both force and displacement must be present in a body. If a force applied
Sorry.
on a body,
No, no, let's take one sentence and understand, digest it.
okay,
That
ma'am.
whatever
Then,
we are saying, yeah, whatever we are saying is okay?
yeah, ma'am.
Okay, fine. So you agree with it, right?
Yeah, ma'am.
Then,
If a force applied on a body does not produce displacement in the body, scientifically, work is not done.
so you agree? You agree or not? That I am applying a force to a body and the body does not move.
Yes, ma'am.
Do you think, now, according to scientific definition, the work is not done because the body is not displaced? But you are sweating out. You are applying energy, but you are doing work, isn't it?
Yeah, ma'am.
We are doing work, no doubt about it, but it is not shown. So scientifically, the work is not done, but actually you are applying force. You are working, but it is not shown. Am I right? Because the object, for example, you pushing the wall, you are pushing the wall. The wall moves. Hello? Does the wall move?
Yeah, ma'am.
No. But you are applying the force, isn't it? You are working, no doubt about it. But according to the scientific definition, the work is not done. Why? Because the wall remains intact. The wall does not displace. But you are tired by pushing the wall. Am I right? Am I right?
Yes, ma'am.
Hello. Yeah. Now we'll do examples to show how we are doing the work. Yes, start. The first one. Yes, continue.
Examples: a man holding a book in his hands in a stationary position does not do any work since the weight of the book acting on him does not produce any displacement.
This one. He's holding a book. Like, fine, let's take. You, as an example, you are holding a book. But you are holding a book. The weight of the book is on your hand. You can feel the weight of the object, yes or no? So you are
Yes,
doing
ma'am.
the work by holding the book, aren't you?
Yes, ma'am.
You are doing the work, but it is not shown. It is not shown because there is no displacement. You are like a statue, you are holding the book. So there is no displacement. So the work is not done, but actually you are doing the work. You are feeling heavy. Your hands are paining by holding the book. Am I right? Am I right? Because which force is applied on the book? The weight of the book. The weight of the book is due to which force? Can you tell me? You feel the weight of the book on your hand is due to which force? Can anyone tell me? Hello? You can see the arrow down. It is the gravitational force. Rita, please think and rethink. I may not be asking you straight questions and make you think all the time. Is it okay with all of you? Hello? I want you to ask me questions. Boys, do you understand me? Hello? 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 Can you hear me?
Yes.
Yes? So I hope you understood. What did I ask you just now? Why do you feel the weight of the book? Obviously, there's a force which is applied on the book. Which is that force? Gravitational force. And hence you get the weight of the book on your hand. Due to this force only you feel the weight. Otherwise, you would not feel any weight. Right? Okay. Now let's see the second example. Please begin. Hello. Please continue. Please continue with the second example. Hello, Shaheen. If you are not able to, then Abdul can take up. Abdul, continue, please.
Hello, ma'am.
Yeah,
Now I'm
continue with
doing.
it.
A man trying to push a rigid and stationary wall does not do work since the force
Force.
applied by him does not move the wall.
You understood the same thing I had started with, that you are pushing the wall. You're working, no doubt about it. You are sweating out. You get tired, but the wall does not move. Okay? So you don't do any work according to scientific definition. Am I right? Hello? So what is over here? Work is equal to what I've shown you? What I've shown you, Vita? Say, work is equal to, hello? Something wrong? Hello? Can you hear me, Vita? Hello?
Yes.
Yes. Give me the answer. What I said. What you see over here in these two examples. Work is equal to 0. You're not doing any work. In spite of you doing work, what is the calculation? W is equal to 0. You understand? Do you understand better?
Yes, ma'am.
Okay. So I think we call it a day. The time is already up. This much, is it absolutely clear? Is there any sort of doubts regarding the work?